5, AMC 12B, problem 24. How many real numbers satisfy the equation sine of 20 pi x is equal to log base 20 of x? So this is a question about the intersection of two graphs. So oftentimes it's helpful to draw a diagram. So we can draw our coordinate plane. In fact, I'm going to draw it like this. Okay. So let's just think about from 0 to 1 first. We can worry about later numbers later. Just for the sake, because this is where a lot of the action is going to happen. Like there's going to be a lot of interesting movement of the log function. So in particular, the log function isn't very interesting. Well, what I mean by that is that the log function is only going to intersect with the sine function at very specific instances, because we know the sine function is going to be between -1 and 1 at all times, but like sine of anything is going to be between -1 and 1 at all times. So the only time where the log function is really going to intersect with the sine function is going to be between when this function outputs -1 and 1, right? So when does this function output -1? Well, that's when x equals 1 over 20, and it's going to output 1 when x equals 20. So every single solution to this equation has to be between these two values. So first, we're just looking at the range between 0 and 1, but then we can think about what it looks like for 1 through 20 as well. So what does this graph look like here? Well, log base 20 of x, I'm going to let this be -1 as well, and this is going to be +1. So what does the log function look like? Well, it's going to go up until we hit this point here. This is the point 1 over 20, common -1. So as we just talked about, when you plug in 1 over 20 into the log function, you get -1. Okay, and then it's going to go up, 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 and it's going to hit this point here, right? It's going to hit 1, 0, because log base anything of 1 is always 0, because anything to the power of 0 is 1. And then what does the sine function look like? Well, I'm going to draw that maybe in a different color. So it's going to go up towards, in fact, this is pretty difficult to draw, but we can think about, well, what is it going to do? It's going to go like up and down and up and down. And it's actually going to go up and down at a very fast rate. Because if you think about it, 20 pi, that's like about like maybe 60 or something. Sine of x would go like this, right? It would, like that. But by doing sine of like 60x, that means that by the time x is only 1 over 60, it's already going to be like the y value is going to be sine of 1. So it's going to shoot up and then shoot down and then shoot up and shoot down very fast. So at exactly what points is it going to go up and back down, right? Well, we can think about this. Well, we know that the zeros of the original sine function happen at the multiples of pi, right? So we know the sine function here, sine function, this is 0, this is pi, this is 2 pi, this is 3 pi. So at every multiple of pi, it crosses over the x-axis again. So in this case, we can think about when is the next 0 going to be. So of course, x equals 0 is the first 0. When is the second 0 going to be? Well, that's going to be when 20 pi x is equal to pi. So when x equals 1 over 20, we see that we get sine of pi, which is going to be 0. So basically, what that means is that the function is going to go shooting up, hit 1, and then by the time the logarithm function is -1 down here, it's actually already going to have hit the x-axis again. And then what's it going to do next? It's going to go down, whoop, and then back up. Going to go up, and then back down, down, and then back up. And it's going to do this up-down cycle a total of 10 times, right? So basically, this is the 1 over 10. Right, so this is 1 over 20, 1 over 10. So it does this up-down cycle once. It does it again, twice, 3 times, 4 times, etc., 10 times, right? And then it finally, after doing that, like this pattern here 10 times, it's going to reach 1. So how many intersections did we find between 0 and 1? Well, we know that there's this like loop here that happens a total of 10 times, right? Because this up-down cycle happens 10 times from 0 to 1. And each time we have a loop here, Well, we know it's going to intersect with the logarithm function exactly twice, because the logarithm function is always going to be between -1 and 1, right? Because we saw that between the values of 1/20 and 1, it's always going to be like between -1 and 0. So it's always this curve here, no matter where the logarithm function is, it's always going to hit the curve at exactly 2 points, right? So here it hits it 1, 2. Here it hits it 1, 2. Here it hits it 1, 2, etc. And here it hits it 1, 2 again, where the final point is right here at x equals 1. So between 0 and 1, so if 0 is less than or equal to x is less than or equal to 1, we have found 20 solutions. And in fact, this same idea is going to work very similarly for basically all of the other numbers from 1 to 20 as well. So I'm going to draw like the rest of the axis. So ignore the fact that the scaling is going to be completely off, but I'm actually just going to put 20 like over here. So now we're going to think about what happens for the rest of it, right, from 1 to 20. So remember that this function goes up and down, up and down, up and down, up and down, up and down. Right, the sine function. It goes up and down. How many times is it going to go up and down? Well, we know between 0 and 1, it went up and down like 10 times. Between 1 and 20, it's going to go up and down 10 times for each of the distance of 1. So there's 19 of them, so it's going to go up and down like 190 times. Okay. So we have like 190. So it's going to be this is like the first time it happens. That's the second time it happens. That's the third time it happens. And then dot, dot, dot. And it goes all the way after 190 times of doing this up-down cycle, it's going to reach 20. And what's the logarithm function going to do? Well, it's just going to go from 1 up. Ooh, it's going to go very slowly because the logarithm function grows very slowly. And finally, it's going to reach the point 20, comma 1 here. Right? So remember before 1/20 comma -1, it can't possibly intersect with the sine wave because the sine is at least -1. And after this point 20 comma 1 here, it's going to be greater than 1, so it can't intersect with the sine function as well. Okay. So we see that basically we don't even need to really think about exactly what this curve looks like. Like it's not exactly a perfectly straight line, but it might as well be, right? Because the whole point here is that since it's just increasing from 0 towards 1 while going very slowly upwards from 1 to 20, it's just going to intersect with each of these different like loops here exactly twice, right? So it intersects with this up down, right? It's going to intersect at the point 1. And this point, it's going to intersect this point at the second cycle around, going to intersect this point at the third cycle around, and it's going to intersect with all of them, including this one twice, right? It could never intersect with one of these only once, because in that case, it would have to somehow be like already at the 1 point, but we know that it only reaches 1 when x equals 20, right? So at this point, at the 190th time it goes up down the sine function, it's still going to be very slightly less than 20. In fact, this diagram's inaccurate. It's probably going to look more like this. It's going to barely be like right below where the peak is, but it's still going to intersect twice. So essentially we get 190 times 2 for each of those U shapes equals 380. And remember, these are the solutions for 1 less than or equal to x less than or equal to 20. So now you could just add the number of solutions together, 20 and 380, and, well, you would get the wrong answer. Because, remember, this is why we should always be careful while thinking about the cases of our problem, right? So we, in this case, when we counted all of the loops, the like down-up loops, right? The last one ended at 1. So we made sure this bound here, that x is not strictly less than 1 here. We were looking at all the numbers from 0 to 1 inclusive, right? And similarly here, when we were looking at these like loops going up and down, right? The first one started at 1 as well. So that's why this bound was important, right? It's not x greater than 1. It was x at least 1. So in particular, the two intervals we looked at here for solutions, we saw that there are 20 solutions from 0 to 1 inclusive and 380 solutions from 1 to 20 inclusive. But we actually, in the process of our method, we double counted the x equals 1 solution. So we have to subtract that one off, and our final answer is going to be 20 plus 380 minus 1. That's going to be 399. After you qualify for the AIME, make sure to check out our latest AIME preparation book with 5 practice tests to consider to continue your Math Olympiad journey. And you can explore our full collection of AMC preparation books at MathTopia Press on Amazon, which include full practice tests and detailed solutions.